So, what's the secret link between the clothes you buy and, say, the flights you book for your vacation? Well, it turns out there's this hidden science, a really powerful discipline that's shaping our world kind of from behind the scenes. Today, we're going to pull back that curtain and see exactly how it all works.
All right, let's start with the puzzle, and it's about a company I'm pretty sure you've heard of, Zara. You know how they get new styles into their stores at like lightning speed? It's pretty legendary in the fashion world. But how do they actually pull that off?
Okay, so it all starts with just a flood of data. Their teams are getting constant feedback from stores, they're analyzing what you and I are actually buying, and then they're sketching thousands of new ideas, almost in real time. Think of it like this massive first step in a giant funnel.
Right, so from that huge pool of designs, they've got to make some really tough calls. Which of these items should we actually make? And not just that, but which factory is the best one to make this specific shirt or that specific pair of pants? And of course, exactly how many of each should they produce?
Now, you'd think the clothes would just go straight from the factory to the store, right? Nope, they don't. Everything, and I mean everything, from every single factory gets shipped to one gigantic central hub in Spain. That's where it all gets sorted and packed. And from that one hub, the right boxes have to be sent to the right stores with the right number of items all across 78 different countries just to meet what people are buying locally. I mean, it is an incredibly complex dance. So, what's the secret? How is this even possible?
The answer? It's a field you might not have heard of, but trust me, it's the secret weapon behind companies like Zara and so many others. It's called operations research.
So what is it? Put really simply, operations research, or OR for short, is all about using science and math to help businesses make the best possible choices when they're facing these super complex problems. It's about replacing guesswork with a solid method for finding that one single best, or what they call the optimal answer. And you know what? This isn't some new flashy tech trend. OR was actually born out of pure necessity during World War II. It was developed to help the military solve these massive logistical puzzles, like getting supplies and troops to the right place at the right time. And then, after the war, industry leaders had this light bulb moment. They realized these same powerful methods could totally revolutionize manufacturing and business. Okay, so how does it actually work in practice? Well, the core idea, the absolute key to the whole thing, is something called a model.
So what OR does is it takes a messy, super complicated real-world problem, with all its unpredictable parts, and it translates it into a simplified mathematical model. The best way to think about it is like creating a clean, easy-to-read map for navigating a huge, complex city. You're not looking at every single tree and car, just the key roads and landmarks you need to get where you're going.
Yeah, as the source material says, a model is an abstract depiction of a problem. It's not the real thing, right? A toy car isn't a real car. A map isn't the actual territory. But, and this is the important part, it's an incredibly powerful tool that lets us test out different scenarios and find the best path forward without any of the real-world risk.
Okay, so once you have that model, you don't just start guessing. Operations research follows a really clear scientific process to find the solution. So let's break down how that actually works, step by step. It's this really disciplined four-step approach. Step 1, you clearly define the problem. What's the goal? What are the limitations? Then step 2, you build that mathematical model we just talked about. Step 3, you use analytical methods to solve that model and find the best possible outcome. And finally, step 4, you actually implement that solution and you keep an eye on it to make sure it's working the way it should.
Now, a problem like Zara's is going to involve millions of different variables, right? It's hugely complex. But the beautiful thing is, the logic scales all the way down. So let's walk through a much simpler example to really see the core principles of OR in action. Okay, so picture this. We've got a farmer with 110 hectares of land. Her goal is super simple: make as much profit as possible. And she's going to do that by planting wheat and barley. But, and there's always a but, she's working with some limitations, or what in the OR world we call constraints. And if you look here, you can see the trade-off right away. Barley brings in more profit, but it also costs more to plant and takes a lot more work. So her first constraint? It's land. She has exactly 110 hectares to work with, not an inch more. Her second constraint is money. She's got a planting budget, and it's capped at a firm $10,000. And her third and final constraint is labor. She only has a maximum of 1,200 man-days of work available for the whole season. That's it.
So here's the puzzle, right? She's got a clear goal, maximize profit, and she's got 3 hard limits: land, money, and labor. So the question is, what is the absolute best mix of crops to plant? This is exactly where operations research comes in. It builds a model to find that single optimal answer.
And here it is, the optimal solution. To get that maximum possible profit, she shouldn't just plant as much of the profitable barley as she can. The model shows the perfect mix is exactly 60 hectares of wheat and 20 hectares of barley. And this is the really cool kind of counterintuitive part. This solution means she doesn't use all her land or all her money. It finds the perfect balance to squeeze the most profit out of all 3 constraints working together.
Now, this exact same logic, optimizing a goal while having to respect a set of constraints, it isn't just for farming, not at all. It's being used everywhere, literally all around us.
This is the hidden engine that makes our world run more smoothly. It's what's used to build optimal investment portfolios, to create those mind-bogglingly complex airline schedules, to figure out where to spend advertising money. And this is why this all matters. From the price you pay for a plane ticket to how efficiently a hospital schedules its staff, OR is the science of making smarter decisions on a massive scale. And it really does impact all of our lives. So that kind of leaves us with a final thought, doesn't it? We all live in a world of limited time, limited money, and really complex choices. So now that you know about this incredible tool for finding the best possible path forward, what's a big decision, maybe in your own life or just out there in the world, that you would want to optimize?